Okay, correcting now question 4 in the Brilliant Guide, page 115 for grade 9. So we are given that an elastic spring elongates by 2 centimeter when a force of magnitude F equal 10 Newton is applied on its free extremity. So we can consider this force to be the tension force. Knowing that the maximum force that can be applied to its free extremity is 50 Newton and its free length without being elongated nor compressed is 20 centimeter, and this is the free length, the initial length of the spring. Number one, they're asking us to calculate in Newton per meter the stiffness of the spring. This means K. So by applying Hooke's law, T equal K delta L, where K is the stiffness, T is the tension force, the magnitude of the tension force, and delta L is the elongation. According to the given, we have delta L corresponding to a certain tension. So we can make use of these two values, T equal K delta L, K equal T over delta L. So T over, we can, instead of writing delta L, we can write it by X or express it or notate it by X. Now 10 Newton over 2 centimeter is 5 Newton per centimeter. However, they asked us to calculate it in Newton per meter, which is the SI unit. In order to convert from Newton per centimeter to Newton per meter, we have to multiply by 100. Then K becomes 5 times 100 is 500 Newton per meter. In part 2, determine the length of the spring in this case. The length, the new length after elongation. So logically, the new length, as long as this case is elongation case, so the new length L is initial length L0 plus delta L, the elongation, which represents how much, by how much was the spring elongated, 20 centimeter plus 2 centimeter, which is given. These both are given. Its new length is 22 centimeter. Part 3, they're asking us determine the elastic limit delta L max of this elastic spring. So in order to be able to calculate delta L max, we have to make use of T max that was given. T max is equal to K delta L max, so since they are directly proportional, T and delta L are directly proportional. Delta L max is T max over K. K was calculated in part 1, and this is a property of the spring, so now we can use it in the upcoming parts because we are still dealing with the same spring. And T max is 50 Newton, 50 Newton over 500 Newton per meter. We get the value in meter, 0.1 meter. If you want to compare it later to given values, we can convert it to centimeter by multiplying by 100. It becomes 10 centimeter. 4. Determine the length of the spring when a mass of 3000 grams is hooked to the free end of the spring. Suppose this is a spring here. I should have drawn it a spring, not a wire. So first, and the object here connected to the spring is 3000 grams. Grams is not the SI unit of mass, so we have to convert it to kilograms by dividing by 1000. It becomes 3 kilograms. Now we need to determine the length of the spring, يعني L. But in order to be able to find L, we first need, just like this case, in order to find L, we need delta L. L0 or the free length is given. So now our objective is to be able to calculate delta L. But how? What can we benefit from the mass? We can simply calculate the weight of the object, which is mass times the gravity, 3 kilograms times 10 Newton per kilogram, considering the object to be on Earth. So it's 30 Newton. Now, what's the relation between the weight and the delta L? The weight and the tension are related, and the tension and delta L are related on the other side. So if you find the tension by using the weight, we can then find delta L. Now, since this object is considered to be at equilibrium, and the only two forces acting on it is the tension by the spring and the weight, or both are vertical. So for it to be at equilibrium, the magnitude relation between these two opposite forces is as such T equal W, which is equal to 30 Newton. In this way, we got the magnitude of the tension. So applying Hooke's law, we can find delta L, T over K using K that was calculated previously. And the answer is 0.06 meter. We converted then to centimeter, which becomes 6. Then we, in order to find the new length, in this case, L0 plus delta L, 20 centimeter plus 6 centimeter is 26 centimeter.